I am Dr. B, your chemistry teacher, and today we are going to look at naming of alkenes. How do we name alkenes? Do not forget that in our previous class I have told us that we were going to take a look at the naming of alkenes before we move into alkynes. Don't forget that you need to share this class. Don't forget that you also need to subscribe. When you share this class to your colleagues and in groups, tell them to subscribe. Subscription is free. You don't pay any money. All you need to do is to subscribe, and so these videos come up and they will see them and follow this beautiful work that we are doing here. Now, do not also forget that there is a Facebook component of it. When you share it through Facebook, you tell them to follow. It doesn't cost anything, so that they can always be having these classes popping up as soon as they go online. Now you can also leave comments in form of questions or appreciation at the end of the day. Both the Facebook and the YouTube channel, the Facebook name and the YouTube channel name are simple Dr. B Science Classes. Once you type Dr. B Science Classes, it's over. Alright, today we are going to be taking a look at naming of alkanes. Now remember that we had mentioned in our previous class that alkanes are simply unsaturated hydrocarbons. And we said there's a reason why they are classified as unsaturated hydrocarbons. And one of the principal reasons why they are classified as unsaturated hydrocarbons is because they possess double carbon-carbon double bonds. Alkynes are also unsaturated hydrocarbons because they possess carbon-carbon triple bonds. Alright, so with the carbon-carbon double bonds, we can classify comfortably alkenes as unsaturated hydrocarbons. Now, it doesn't end there. Another cardinal reason why alkenes are classified or grouped as unsaturated is because they do not have their carbon atom, their central carbon, or perhaps you can say their carbon atom completely bonded by 4 different atoms. Okay, now that what makes it different from even the alkanes, because the alkanes have their central carbon completely bonded by 4 other atoms. But it is not the same, or it's not the case with the alkenes. Alkenes do not have their central carbon completely bonded by 4 other atoms. Now, that is the cardinal reason why alkenes are described as being unsaturated, added to the fact that they possess carbon-carbon double bonds. Okay, it's also important for us to know, like I had mentioned when I discussed the class on alkenes, in our previous class, I had mentioned that alkenes undergo addition reaction. Now, they are unsaturated hydrocarbons, and that addition reaction is what makes them very, very different from the alkanes. Today we are not discussing on alkenes. We have already done that class already. You can visit Dr. B Science classes and take a good word and listen to that particular part of the lecture. Today we want to look at how we can name alkenes. Now, all these compounds that are written here are different alkenes compound. Now, one will ask you to name them. One of the beautiful things around organic chemistry is your ability to name alkenes. To name alkenes, alkynes, in fact, to name hydrocarbon compounds. And we're going to take a very short look at that. Now, there are processes to which you must take in order for you to be able to name these alkenes, even alkynes, as the case may be. Remember that we said that alkenes are what they are because of the suffix which they have ending with the ene, just like the ane suffix which ends for alkanes. Alright, now for us to be able to name alkenes, the first thing we must know is to identify the parent chain. That is number one. Number one is you must be able to identify the parent chain. The parent chain. That is the first thing you must know. You must be able to identify the parent chain. And when we say the parent chain, what we simply mean is that for every alkane compound or hydrocarbon compound, there is a long chain of of carbon atoms that are linked by different bonds. Now, this long chain of carbon atoms that are linked by different bonds also contain double bonds. You must be able to identify what compound is that, what compound name is that. Now, if you take a look at the whole of this, you'll see that there is carbon here, carbon here, carbon, carbon, carbon. All these are linked together by single bonds, and there is a carbon double bond. So when we say a parent chain, we are talking about the entire compound that you see here with its backbone. Be able to first do what? To identify this particular chain. And by identifying the chain, it means that you must understand the different homologous series that bind the alkanes. That is just it. You must understand the homologous series that binds the alkane. You must be able to know the different alkanes compound. Just like when we talk about alkanes, we're talking about methane, talking about ethane, talking about propane, butane, pentane, hexane, and all those stuff. You must also understand that in alkenes you also have things like ethane, things like propane, butane, okay, pentane, and all those stuff. Hexane, heptane, octane, and up to decane. So all of them have end with the ENE. So for you to be able to identify the parent chain, you must be able to know the different, at least the first 10 structure, the first 10 homologous series of the alkenes. Now, if we take a look at this 1, 2, 3, 4, 5. So it means that identifying this particular parent chain, we were talking about what? Talking about what? Pentane. So this means this is what? Pentene. That's what it means. So to identify the parent chain, we must know, it means that we must know what category or what group of hydrocarbon, especially in terms of alkanes, that this particular chain or this particular compound belongs to. So we have 1, 2, 3, 4, 5 carbon atom, and the 5th carbon atom in the homologous series of the alkanes is pentane. Because the fourth one is butene. And the third one is propane. Okay, so that is the first step. This is the first step. Identify the parent chain. Once you are able to identify the parent chain, then you started making the work easier for you to know how to do or to name the alkenes. And now we have identified the parent chain for this. That we're going to do for all of them before we end this class. So we have identified the parent chain. The parent chain here is pentene. Now, the next thing you need to do is to be able to number the chain. You must know how to number the chain, because when you see when you are naming organic compounds, especially those ones that have turn around alkenes and alkynes, you'll be seeing numbers that are being called in them. Maybe something like pent 2 in, pent 1 into methyl butane. You will see numbers that are called in between. So if you are able to identify the parent chain, the next thing is to number the chain. And you cannot just stay like this. You cannot just start numbering the chain anyhow. There is a convention to numbering the chain of an alkane compound. So if you take a look at this, we cannot just start numbering 1, 2, 3, 4, 5. We cannot just start numbering 1, 2, 3, 4, 5. Of course, numbering the chain means you should number the carbon atoms. Now, to number the right convention to number the carbon atoms in compounds like this is to understand it from 2 dimensions. One is that you must start numbering your carbon atoms in this chain beginning from where you have the carbon-carbon double bond. The carbon atom that precedes the carbon-carbon double bond, or precedes the double bond, which is of course nearest to the double bond, is where you start your numbering. But sometimes it doesn't work like that. Now the second convention will come in. In a situation where you have the double bond equidistance between the carbon atoms, that is to say you have 1, 2, 3 carbon atom, double bond, 1, 2, 3 carbon atom, like you are seeing in this kind of a situation. You have 1, 2 carbon atom, 1, 2. That means that there is 2 carbon atoms to a double bond, 2 carbon. How do you begin to name this? Because as it is, the carbon atom is not closer to any other carbon atom that begins. So you cannot be able to use this convention that I've just mentioned here to name this one. In that case, where you have the double bond being at equidistance between the carbon atoms, you have to start looking for a methyl group or any other group that is attached to that particular compound. So it means that you may have to start naming that compound, or rather numbering that chain from where you have the carbon with a methyl group or any other group attached. So it means that in this kind of a situation, if we want to do what? To name the chain, which is the second convention, we said you should do what? Number the chain. Number the chain. We have known how to identify the chain following the homologous series of alkene. Now to number the chain, we said there are two conventions. One, if you must number the chain, then you should be able to understand the fact that the carbon atoms you are numbering, the first one that you will start with, number 1, should be the one that is closer to the double bond, especially preceding the double bond, like this one. This will now be our 1, this will be our 2, this will be our 3, this will be our 4. If we are following that convention, which means that we must number beginning from the carbon atom that is housing the double bond, closer to the double bond, most likely preceding the double bond. Okay. Now, where it becomes impossible, like I said, the second convention is that where this does not work, you rather have a double bond that is equidistant between carbon atoms. You have 1, 2, double bond 1, 2. In this case, you will not be able to tell which of the carbon atom do I supposed to start numbering first, because it is it from here or is from here, since this is not closer like this. In that case, you will now start looking for this particular moiety. You start looking for any particular group that's attached to a carbon atom. That carbon atom that bears that group that is attached, it is from that side, that end, you will start the numbering. Which means that if we are supposed to be numbering this one, because it has double bond that is equidistant, we will start from here. 1, 2, 3, 4. That's what it means. This is because both there are 2 here and there are 2 here. This is in equidistance. We'll start numbering from the side that has a carbon atom that bears a methyl group, or any other group at all. So that is how you name. That is how you name. That is how you number the chain while trying to name alkenes. First, I've mentioned identify the parent chain. Second, I've mentioned number the chain itself. And I'm sure you are following these steps. I am putting them down. Now, if you complete this particular numbering of the chain, then the next thing you need to do is indicate the position of the double bond, because the double bond is not in a particular place. If as a compound varies, so double bonds varies as well. So you need to do what? You need to be able to do what? Identify, to indicate the position of a double bond. And that is the tough thing that you need to do. You need to do what? You need to identify, or let's say, okay, let me use a more valuable word. Let's say indicate, because you are not going to identify. Indicate the position of the double bond. Okay, that is the third thing that you must do. or you must know while naming alkanes. The first one, you are able to identify the chain. Second one, you number the chain. The third one indicates the position of the double bond. You must know where the double bond is. So which means that if you number this in this way, you must identify or indicate where the double bond is. Which carbon atom are we supposed to be naming the double bond? Remember that naming the double bond means that at the end of the compound you have been able to identify, it must end with an ENE to show that it's an alkene. But we must know where the position of the double bond lies. For example, in this one, the position of the double bond lies here in the first carbon atom. In this one, the position of the double bond lies here, but of course, in the second carbon atom. Here, it also lies here in the second carbon atom. And then here, it lies here, of course, 1, 2, 3, 4, in the third carbon atom. You must be able to identify the position of the double bond. Now, if you have been able to identify the position of the double bond, then you need to move ahead immediately to name the what? To name the substituent. You will name the substituent, which is the fourth thing you need to do. You need to name the substituent. Okay, 4. So you name the substituent. You name the substituent. And what do you mean by the substituent? These attachments. If you have any methyl group attached to any carbon atom in the compound, you must name it. If you have an oxygen atom or OH atom, because if it's a hydroxyl group, okay, that means that here we'll be having OH. You must be able to do what? To name the substituent. If it's an OH group, it is what? A hydroxy what? Group. If it's a CH3, it's a methyl group. That is it. Okay, so you must be able to identify that. If it's a CN, it's a cyano group. Okay, just like that, like that, like that. Okay, so once you are able to identify that particular substituent that's attached, like I said, if it's CH3, it's a methyl group. If it's an OH group, it's an OH substituent, it's a hydroxy group. If it's a CN substituent, it's a cyanide group. You must be able to identify the group. And then finally, which is the number 5, you will do what? You will construct the name. So you will do what? You will construct the name. You construct the name. So by constructing the name, you must understand the fact that it's an alkene, so the name must be ending with E-N-E. Now we are going to construct the name now. After we have dealt with what? Dealt with the 4 basic stages. The 5th stage is to construct what? The name from the understanding of the 4 basic criteria. Now we take a look at this. The number 1. If we follow the convention which we have said, 1, we do what? We identify the parent chain. Now we say this is 1, 2, 3, 4, 5, and it's pentene. It's not pentane because it has a double bond. It is what? Unsaturated hydrocarbon. So it's 1, 2, 3, 4, 5 is what? Is pentene. That's the first thing. Second thing was for us to do what? Was for us to be able to name or number the chain. Now we have already numbered the chain. If we are following this one in numbering the chain, of the chain, the double bond is closer to this carbon atom. So we'll start numbering from here. 1, 2, 3, 4, 5. We have numbered the chain. Now the third one is to indicate the position of the double bond. The double bond is in the first carbon atom. Okay? Now the 4th one is to name the substituent. There is no substituent in this place attached to the carbon atom. So what is the name of this? We cannot just call it pentane because we have to indicate the position of the double bond. The double bond is in 1, closer to 1, is in 1. So we rather say pent1 in. And that is why this compound can be called pent1 in. This compound here is called pent 1 in. Okay, pent 1 in. That is this compound. Like I said, pentene. Ordinarily, we'll have just said pentene. If there was no double bond, we'll have said it's pentane. It's pentane. But because there's a double bond, there's need to understand that it's an alkene. The E suffix must be added. And the fact that the carbon atom, sorry, the double bond is in the first group here, we have to indicate the position, which is 1. So 1, 2, 3, 4, 5 is pentene. So we say pent. The double bond is in the first carbon atom, we say 1. And since it is an alkene, we say in. That is 1, 2, 3, 4, 5. Pent 1, and we'll add the in. Else we'll have just said pentene. But because the position of the double bond is in 1, we must bring the 1 inside and cut the pentene. Put the 1 in the middle. And that is why you have pent 1 in. Okay, the second one, how do we start naming it? First, we identify what? We identify the parent chain. This is 1, 2, 3, 4, 5. So it is still what? Pentene. It's still pentene. Now the next thing is for us to number the carbon atom. Where do you number it from? If you check the whole of this, 1, 2, 3, 1, 2. So it's not equidistant. That second criteria did not work. We take the first criteria, which still means that we will number it based on what you have here. Carbon atom is closer to this side than to this side. So we have 1, 2, 3, 4, and 5. Do we have any with the double bond? Yes. The position of the double bond is in 2. It's closer to the 2. Do we have any substituent here? No. Nothing is attached to the carbon atoms. So, what is the name? Since it's pentene, but there is a double bond in the second carbon atom, we call it what? Pent 2 in. And that's why this compound is called pent 2 in. Pent 2 in. Very beautiful. So simple. Just follow the criteria, the convention in naming them, and you are good to go. Now, how about the third one? Of course, the third one is 1, 2, 3, 4. It can't be pentane. It's definitely going to be what? Butane. Butane is 4. So this is butane. We have been able to identify the parent name. Now, how about numbering? We have numbered already. Why did we do this numbering earlier? Because the carbon atom is equidistant. 1, 2, 1, 2. We cannot start naming from, we don't know the end to start naming from. We rather start naming from the end that has a carbon atom that bears a substituent. And we check this side, there's a substituent CH3 attached to this carbon atom. So we are going to name from here. So we have 1, 2, 3, 4, and that is butane. The next thing is to indicate the position of the double bond. The double bond position is in 2. It's in this carbon atom, which is 2. This is what precedes the double bond. So it's 2. So it's 2 in the house. Now the next thing is to name the moiety. The substituent that is here is CH3. That is methane. So if you are going to name it, it's called methane. Okay. So sorry, methyl. So we are going to now name it like this. 1, 2. 2 methyl. Okay. 2 methyl. 1, 2, 3, 4. Butane. Well, I say butane 1, butane 2. We can't do that. So we say 2 methyl. Since the methyl group is in the 2, 2 methyl but 2 in. But 2 in the sense that the 2 is showing that the carbon double bond is also in the second carbon. So we say we have 2 methyl but 2 in. 2 methyl but 2 in. This is because you have 1, 2, the methyl group is in the second carbon atom, the double bond is in the second carbon atom. So you have what? 2 methyl, 1, 2, 3, 4 butane, 2 methyl but 2 in, because it's an alkene. Thing was butene. And then the fourth one here shows that the carbon atom is close, the double bond is closer to this carbon atom, even though there is a substituent that is here. But the fact remains that this double bond did not divide these two in the middle like this one. So this is smaller, this is 3 carbon and this one. So we cannot use this convention to name this. We'd rather go with the other convention where the carbon double bond is closer to what? To the carbon atom, that side that is shorter. So we now start numbering from here. So this is 1, this is 2, this is 3, and this is 4. Of course, if it is 4, 1, 2, 3, 4, the parent chain is simply butane. Because 1, 2, 3, 4 was butane. So 1, 2, 3, 4 is butane. So if it's 1, 2, 3, 4, it is butane. Now the double bond, the numbering has been done. The double bond is closer to this carbon atom, which is 1. But there is a substituent that is in 3. And how do we now name it? Simply, the substituent is in 3 carbon atoms, so it is 3-methyl. 3-methyl. 1, 2, 3, 4, but 1 in. Because the carbon atom is, sorry, double bond is in 1. So this is 3, this is 3, this is 3-methyl group, but 1 in. This is 3-methyl, 3-methyl, 1, 2, 3, 4, but, because this is in 1 in. 3-methyl, but 1 in. And finally, we have this here. And so you should be able to take this home as an assignment and work on it. The important thing is that there is 1, 2, 3, 4, 5, 6. So it is what? The parent chain there. Naming that or identifying the parent chain here is what? Is hexane. So if it's hexane, how do we name it? That is your assignment. Go to my comment section and treat this as this number 5. Treat number 5 as your assignment. Name this compound with 1, 2, 3, 4, 5, 6. With 1, 2, 3, 1, 2, 3 carbon atoms equidistant with a methyl group attached. Name the compound and post it on the comment section of either the Facebook or post it in the comment section of the YouTube, and we are going to see who is actually following this lecture and who is doing well also in it. Dr. B Science Classes is the name, both in YouTube and also on Facebook. It's nice having this class with you. Until next time, it is bye.